Hello everyone, good afternoon. Welcome to C++ Code Lab. In today's lecture, we'll be talking about variable and data type. So if you have been coming or like we have started this lecture with us, so you will try and understand this is one of the topic we have been waiting for to understand, because we have been using variables and data type and without not explanation or without deep explanation. So this is the topic here. So in today's lecture we'll be talking about variables and data types. So now this we have integer here, which is here. So we should be familiar with these codes if you have been coming along with us. So this particular code here, we have int and we have box here, which is the integer which represents our data type, and we have box which represents our variable. So before we go into the before we get into this process of using the data type and variable, we have to understand one thing. There is one thing left behind we should try and understand. It is called number systems. So it is a process whereby you understand how every value, like now I gave, let's just come lower here. So I gave the value of 20 to this particular data type and variable here. So I gave the value of 20 to this data type and variable here. So we have to understand how our value is being treated in the memory, how it is being treated in the memory, before we can actually go into this particular topic, which is variables and data type. So we have to understand this particularly how our data is being stored in the memory in a binary format. Let me just break it down. We have to understand it in a binary format, how our data is being treated in the memory. So now we'll be talking about this specific number system, which is the binary. We're talking about the binary. We'll be talking about the octals, decimal, and the hexadecimal. So before we go into this lecture, the number systems, let's try and review what we have been doing from start. So we have treated the main functions, the entrance points, and the main function. You know that our code start from the main function, which is the entrance point. So we should know these are actually you should know this particular code and this code, they are just like of the same type, or let's say they are familiar, they are related to each other, because start from, I don't want to go too long there. So now we have entrance points, we have functions. So we have functions, we have errors. So we should understand errors. You should understand what warning is, input and output. You should understand what this means. You should understand the comment sections, how you declare your comments, and the workflows, and this memory module, and the execution module. So you should understand this particularly topic. I hope you should have understand this topic we have treated in the past lectures. So we're able to understand what we are going to add in the next lecture. So today's lecture we'll be talking about number system, and if you go to this lecture here, every details or your value is being represented in this format in the memory. They are stored in bits. But before we go into the knowing of bits, let's try and understand this particular word here. So first thing here, our data, our programming language, on the norms as a programmer, you should have this knowledge of communicating to your computer directly. That is the way the computer is being designed on the norms. But until the introduction of the programming language is being invested for us to be able to have a very easy access to the computer, to have our words or to have our desire being printed or being developed or being created to the string or to whatever development you are actually hoping to work on. So on a norm, it is binary format that is the computer understand. Before the introduction of the programming language, that has all this text, that has the text string, that has all these particular features which you have to use numbers, no, text or any symbols to communicate with the computer just to give us our desired output. But on enough, this is the way our data there is being stored in zeros and one in the memory. They are stored in zeros and one in the memory. That's the ways our data has been treated. They are stored in ones and zeros in the memory. So our data has been stored in a bit format. So a bit is being stored in a bit format. So 8 bits here makes a byte. So we will talk about that some more when we get to the next level. But first thing you want to understand that your data is being stored in a bit format, and 8 bits makes 1 byte. 8 bits makes a byte here. So our format is being stored in a bit format in the memories. But let's try and go to the next lecture here, let's go and go to the next slide, which is this one here, which is this what we have here. So number systems. So number systems is a format whereby we have a clear and a very deep understanding of how our numbers or our data is being treated. Not just numbers, just it's data, not numbers only. It works with data like that. So now our number is being shows up in the memory, how the computer understands every numbers we are right or in this particular format, in binary format, in hexadecimals and in octals and in octal and in hexadecimal format. So in the next test here we're gonna have base 10s. So here we are using real life number, which is the whole number we have here. We have 1291. So in base 10, the reason why we introduced this format is because that is one way our binary is being treated. Also converting or treating our numbers decimal number. But let's try and do something. Let's try and make up something with this thing we have here. So I don't really think it's necessary, but though let's just try and go in details. Like I said, you have to spare me your time and your patience and tolerate. So you have to tolerate this for me. I'm so sorry. I hope you won't really get so annoyed with me. So now the first number we have 10 in base part 3. So we're gonna multiply it, and though we don't need calculator, and we can even pop out calculator, so we can have a very clear of what we are doing. So 10, let's just say 10. Let's bring this up, and I want to shrink it. Okay, it can't really shrink. So now I'm gonna bring this up and say 10 times 10 times 10. So it's gonna be 1000. Oh no, this is error. 10 times 10 times 10. So it's gonna give us 1000, and we have plus in the front. So 1 times 0 is 1 times 1000 is gonna be 1000. So we don't need to do that. So now we're gonna have 2 times 10 raised to power 2. So what's gonna do here is that we're gonna say 10 times 10. So that's 2. Then 100 times 2 times 2. So it's gonna be 2000. So plus we have 9 here, so it's gonna be 9 times 10 raised to power 1. So raised to power 1 is just 1. We don't need to multiply raised to power. We don't need to multiply this. Why did I click those up? So we don't need to multiply this we have here. So we're gonna have 9 times. We're gonna have 9 times 10. It's gonna be what? It's gonna be 90. So it's gonna be 90, and we have 1 times 10 here. So this is actually 10 times 0 is gonna be 0. Or am I correct? 10 times 0 is gonna be 0. Yeah, times 1. Actually, though the number is supposed to be 1, the number is supposed to be 1. It's 1. So let's just make it 1 because we have 1 over here. So now if we multiply all this together, it's gonna give us this. It's gonna give us this particular one we have here. So if we should multiply, we should add this together. So 1000 plus 200 plus 90 plus 1. So give us this specific number we have here. So that is exactly one way we can actually deal with base number in a real life format. And let's go to the next slide. So if you should ask what is up here, we're going to give us the same thing we have here, and also in this specific place too, it's going to give us what we have here. So I think you can deal with that yourself. And let's go to the next slide here. And here we have base 2. So we are using base 2 formats to get our binary in decimal point number. So now let's try and do something with this. So we can actually do this in a decimal. We're going to get our decimal number. We're going to use this binary to get our decimal number. You'll be using base 2. So this is what we're going to do. We have actually do the computation here already. So we're going to use this one here. So we're going to do 2 times 2 times 2 times 2 and times 2. So it's going to give us 32. Am I correct? I think I have added more than I should. 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Okay, I think I should be right about that. I should be right. 2 times 2 times 2, that's 3, times 2, that's 4, times 2, that's 5. Yeah, we are right actually. So now plus 4 times, no, it's gonna be 0 at the end. It should be 0, because if we should multiply these together, if I said 2 times 2 times 2 times 2, it's gonna be 16, and 16 times 0 is gonna be 16 times 0 is gonna be 0. So what we have here is 0, and let's go to the next one here. We're gonna have 3 times 2 times 2 times 2. So it's gonna have 3. It's gonna have 8. I mean, I'm so sorry for breaking errors. So we're gonna have 2 times 2 times 2. So 4. We have 4. I don't know how I have to type all those ones here. So we have 2 times 4, and we have 2 times 0 times 1. So this is gonna be 0, because 0 is already here. It's already represented 0. So we're gonna put 0 here, and next one is gonna be 1. It should be 1, I get. So let's add this up together. So 32 plus 8 plus 4 plus 1. So it's gonna be 45. So our decimal number is gonna be 45. In the memory, if you have this specific binary format representing our 49 data in our code, it's gonna be in this kind of format. So let's check it out ourselves. We will use the same calculator to check it out ourselves. So now let's cancel this, and we're gonna click on this particular side and go to programmer mode. So after programmer mode, you choose binary format, binary method here. So which is this one here, and you just type it as 101101. So you see what is a decimal point in decimal, which is DEC is 45, and it's exactly what we have here. So that is one way you calculate, or you can solve your binary using base 2, or using base to solve it to get your decimal point number. So in Octal it is 55, and in Hexadecimal it is 2 and D. Though we're gonna be talking about Hexadecimal and Octal, but you should know what decimal is, which is all number we have in the real world. The numbers we use, number is 0, minus 0 to plus, or thousands to whatever thousands you have. So this is just the number we have. You have seen it here, and thank you for that, going along with me. So if we should add up what we have here, we get, let's try and check what is there. So let's try and check what is there. So cancel, you're gonna write 0. Okay, in binary format, actually we're gonna stay in binary mode, and let's close this. We're going to say 1 0 1 1 1, and that is what 1 0 1 1 1. So that is 23 in decimal number. So this particular binary is 23 in decimal. So if we should do this one too, it gives us what we, you can do that yourself and check how it works for it, and you can try more. You can try more and do more a lot, just to understand more about this way this particular section works. So I hope you understand that this is in a binary format, and we convert it to decimal number using base 2 to get the calculation by with this formula or with this particular code and this calculation or computation we have here. And I hope you understand that clearly. And when we go to the next one here, we have 3 digits. So 3 digits in binary format is from 1 to 7. It's been stored from 1 decimal number to 7. So if we should go to the memory part here, so we see how they are being stored in memory. So these are binary formats having the value that can store from 1 decimal point, or 1 decimal to 7 decimal number. So this is the binary format of it, holding the value of 1 to 7. I hope you understand that. And if we should go to this particular decimal number, so we have, if we should check it from this particular side here, we have 001. So we check to this particular code, so 001, so 001, so it's 2. 001 is 2 in decimal points. So try to understand that this is the memories of your computer. This is your binary format. This is the way your data has been stored. Whenever you declare your integer and your variable, they are stored like this in the memory. So if you should input something like 4, if you input something like 5, they are stored like this. So it's stored like 5. Let's say 5. So let's go to 5 and let's look for 5 here, which is 5 is like 100. So if you go to this part here, let's look for 100 100 100 100 10. Okay, this is 100 here. So this is the way your data is being stored. Your data will be stored like this in the memory, not the way you see it in the real world. It is stored like this, 100 stored in this format here in the memory. So that is the 3 digits in the memory. So that's the 3 digits we use stored in the memory. That's the way it's been stored in the memories. So let's go to the next slide here. The next slide we have 4 digits. So in case you have 4 digits binary and they are stored from decimal 1, or let's say 1 to is 15 in this particular format here. Sorry. Okay. So they are stored in this format. I expected to have 0, but I'm coming. 0 0 0 0 0 0 1 2 3 4 1 2 3 4. Okay, fine. So in our 4 digits, our data is stored in this format. It's stored in this way. It's stored in this particular way, whereby we have 1, it's going to have 1 0 0 0, and it's going to have it stored in the memory. So it's going to store our data just the way we have it here. So if you have 1 decimal number in 4 digit memory, it's going to have it here. So it is like this. This is the memory format, or this is the memories of 4 digits. So it's count it. If you have 111 and 111 is 15, which you have here, 111 is 15. So in decimal points, decimal format here is 15. In binary, it is 111, which is stored in the memory we have here. So I think you'll get what I'm trying to say, and I hope it's not getting much difficult for you. So yeah, we are still talking about how numbers has been stored. We haven't really get to the hexadecimal and octal. So we are just taking the decimal part. You are taking the decimal part, and I hope it's not getting really difficult for you to understand. So I think it's easy if you should try and understand carefully. This is the memories of 4 digits, and we have the value in decimal point. We have it stored here from 1 to 15, and this is the representative of the binary format in it, and we have the memory which stores those data here. So I hope you're getting this. And if we should go to the so if we should go or move forward to the 5 digits, so 5 digits is being stored in from 1 to 30. It stores from decimal, the first one, number 1 decimal, that's 1, which is the decimal, and it stops at 50 and 30. So because it has the digit of 5. So if we check the memories of the 5 digits, so we can see that we have it stores like this, and we stored it in this format where we have, okay, let's say we have 0 1, we have 0 1 0 1 0 0 0. So let's check this in the memory or in binary format. So we can actually have it here. You can also use your calculator to check it out. It gives you the same result. So but let's try and use what we have here, and we have 0 1 0 0 0. So here we're going to have 0 1 0 0 0, 0 1 0 1 0 0 0, 0 1 0 1. I'm coming. Sorry, it should be from here. Okay, this is 0 1 0 0 0. So this is here, and it's gonna be 3. So in memory this is 3. In memory this is 3. This is digit 3. So that is the way your decimal number is being stored in the memories of your computer. They are stored in binary format, and they are wrapped up or grouped in this form or in this format. So that is decimal point, or that is decimal number systems. So now let's go and make this. Let's generalize what we have here. So in the first one we know that we can actually use first digit. We can actually do 0 1, and it's from 0 to 1. And in the second digit here, we can generalize it in a way that we can actually use from 0 to 3. So in the 3 digits, this represents the binary. This represents the binary, and this represents your data itself. That's the decimal we are using. So this represents the data itself, and this represents the binary. So the first binary can store from 0 to 1, and the second binary, let's say binary of 2, or let's say 2 digits binary. 2 digit binary can store from 0 to 3, and 3 digit binary can store from 0 to 7. So from 5 digit binary memory, 5 digits of binary can store from 0 to 15. 4. So we have 5 can store from 0 to 30. So that is the way you solve or iterate through this particular section using binaries and your data himself. So to generalize everything, you can actually use this format whereby you use n. This n means any particular number, any particular digit you use. So this represents, it does not specify any specific digit. So it can be any type. It can be any type you use. So it's by 2 raised to the power n minus 1. So if you use this formula there, you can actually get any of your data range being solved. You can get any one of them solved. So I hope you understand what this is, and I hope you get this. So I'm going to stop here for that, and when we go to this particular place here, it takes up deep more. So in practice, we have digits, we have bits, and we have data range. So data range is amount of the memory we have. like the highest memory that we can actually store data. So in a bit we have, so this bit is actually a bit, sorry, this digit actually represents a bit. So 8 bits is 1 byte, which actually shows up here. I didn't really talk about that. I said we will talk about that in the name. So it is actually shows up here. So a bit, or let's say 8 bit makes 1 byte. So the memory here, so we have it here. Sorry. So we have it here. So 8 bit is 1 byte, and we can actually store the data, or the data range can be from 0 to 225. We can actually store from 0 to 225, and we can actually store 16 digits, and it's actually 2 bytes in memory, and we can store the value of 0 to 65,535, and we can store 32 bits or digits. I'm just saying bit, but we can, let's just call it digits, and we can, it's actually 4 bytes in memory, and we can store this range of value in. So this is the range of the value we can actually store in every bit of our memory. So we have 64 bits, and we have 8 bytes, and with this data range, which is very large amount of memory, very large amount of memory. So this is how you store your data in your memory, and this is the data range. This is how big they can be stored in the memories. So like I said, this is a bit, this is a byte, and this is a digit. So a bit, 8 bytes is that give us the byte, 8 bits give us 1 byte, and the data range can be from 0 to 225. And I hope this is clear to you guys. And if we should go to 18, here we have hexadecimal systems, and hexadecimal system is just like the way we explain, or the way we understand decimal, but this is different. This is far different from decimal. It's just like they are just wrapping up in the same section, they are having of the same knowledge like that. But hexadecimal binary format can be in this form and this mode. And let's go to the next one here. We have hexadecimal in the memory here. So if we should go here, we will try and solve our hexadecimal value. So the way our programs or our binary treat our hexadecimal, we're going to be seeing it from the left angle here, or from the left side here. So in the binary, in the decimal number, we're going to be, in the decimal number, we're going to be seeing it, like this, and in the hexadecimal, we're going to be seeing it like this. And but in the memory, we're going to see them all in one format, all in one form. They are having one form here. But yes, we have in decimal, we have 0, and we have 0, and we have 0. The first, that's the first digit we have there, and the next one we have 0, 0, 1, and we have 1. And if you notice that when we get to 9, something happens after. Hexadecimal doesn't have 10. It has A, then it has to F. So hexadecimal digits are from, or is from 0 to 9 and A to F. So any digit you see that is not of this particular digit you see in this place is actually error, not of the hexadecimal value. Hexadecimal value are just what is being listed in this particular place here. Hexadecimal digits are from 0 to 9, and, or let's say 0 to F. So when you get to 9, you stopped. So it starts from 0, 1, 5, 1, 3, 4, 5, 6, 7, 8, 9, and A. Then B, C, D, E, and F. So G is not an hexadecimal value. or let's say k or n, they are not of hexadecimal. Hexadecimal value is from A to F. So, and in the memory or in the binary format, they are stored in these forms, whereby you have in hexadecimal, when you have A, so A is actually 1010 in hexadecimal. So that is one way we have. So if we go to the next slide here, we actually solve some things here. So in the memories of the hexadecimal, we actually solve or sort some things out. So hexadecimal actually takes 4 bits, 4 bits in the memory, which you have here for 4 bits in the memory. So now we have it here that we actually solve what we have particularly have here. So if you check it here, 0 1 1 1, so we have that's 1 1 1. So if you go to this particular side here, so let's say 1 1 1, I'm coming 1 1 1, let's say 1 1 1, so this is 1 1 here, it's F. So it's F that gave us this particular one we have. Sorry, not that. Okay, let's do this thing again. I hope it will straight us. Oh god. Okay, fine, let's just try it. Okay, good. So now 1 1 1, let's try and solve it. Oh god, I even reading it here. They are whole years. They are whole year. Forgotten their year. So to waste or to eat less amount of our time, you can try and do this yourself. And 1 1 1 is actually F, and in binary format here, this is it in binary format. And if you check it through using this method here, you're gonna be seeing how it works. And you can also use your calculator to check that through, but you can use any format you want. You can do it in your manual, you can do it manually, or you can write it up, or you can just use your calculator any way you feel like. But just try and understand that this is the way they are being converted in the memory or binary format. So F in hexadecimal is 15, so in binary is 111. So E in hexadecimal is 14, and in binary it's 1110. So if you get to the next one, we have D, it's hexadecimal, it's 13 in decimal, and it is 1101 in binary. So when we get to this hexadecimal system, so we try and get some things, and we get through this first line, and we sort it, and we get this particular result. And this is the memory, this is the value of what is stored in the first lines we have here in binary format here, which is it in hexadecimal mode. So when we get to this particular one, it's called this. There is something that I want you guys to understand. You might be thinking about it, or you might not even thought about it, but I want you to understand something in binary. But before we understand that, it's okay, I can bring it up. In binary, if we have something like 1 1 1, and when we get to this particular stage, when we have 0 1 1 0, so if you have, or I think something happens. I'm coming. Okay, we have Octal here, but I think let me explain Octal, and after I explain the Octal, I'm going to explain this, so you're going to understand this. So let me explain what Octal is. So sorry guys, I want to explain this padding, but if I should explain this padding to you, you might get confused. So I want to explain this Octal system before I explain this padding. So Octal system actually is not really complicated. Same, and sorry, before I forgot, hexadecimal usually have this particular value in the front. So whenever you have hexadecimal value, you usually put 0 and X before any digit is being written, so your compiler can know, or your compiler can notify that yes, this is a value of hexadecimal. So whenever you are declaring hexadecimal value in your programs, or in your programs here, or in your codes, whatever you might call it, of course, something. So your value should start from the 0 and X, and before the hexadecimal system or hexadecimal value is being written. So usually start with 0 and X. I hope you get that. So now let me explain Octal. So Octal is value that represents of 1 to 7 on its different though, but it has in 3 digits memory, in 3 bits or 3 digits, it stores 0 0, and when it gets to here, it stores its numbers are very obvious here. Just that we didn't really go that deep, but we're gonna explain much about that. So it's just normal that we have it 0 and 0, we have it 1 1, and it's just the same thing, as it has the same value with decimal, but we will try and understand that their numbers, its numbers change in some ways when we get longer than this. But I want to explain this padding in for you. So we're going to be seeing that in this place when we check the binary format of this particular number here, of this particular octal systems here. So yeah, let me explain this padding for you. In padding, or should I explain this one here first? Okay, let me explain octal. Let me explain this binary system before I go to padding. So yeah, there's what we call this binary format of your program or of your octal systems. So in your octal system here, we have 3 digits. It's represented in 3 digits. So we have 1 1 1. So 1 1 1 in the memory here is binary format is 1 1 1 is 7. So we have 7 here, and when we go to here, we also have 1 1 1 again. Let's go back here. It's also 7, and we have 0 1 1. 0 1 1 is where 0 1 1 is 4. So we have it here. We have 4. We have just the same way it is here. So we can solve. But when we get here, you see our value is not complete. We have 0 1 0 1. So it's like the value remained 1. The value here remained 1. So how does the compiler solve that or sort that? This is what happens here. Fine, if you check this particular code here, we have 1 0, and we check here 1 0 1 0 0. It's called 1. It's called 1 here. And if you get to our padding here, so padding says whenever you declare whenever you use your value and it gets in 3 digits in the memories, and we have, or this is actual 4 digits, but let me use this and explain it. So if your value is not complete to round up the value you have, like now you use these particular numbers in the memories, or use this particular numbers in octal systems, and when your compiler or when your compiler sees that this is your value and takes it in the binary system, and when your compiler sees that it has consumed all your value there, what does the compiler do? This is what the compiler does. It uses the last value, or it does the last value we have here. It turns the last value we have here to 0 0. So which is what is happening here. So it turns the last value to 0 0 0. So it makes the last value 0. It converts the last value as 0, and that is exactly what happened here. Where we have this, our last value here, we have 1, which is 1 0. There's nothing else again. If you should count this thing 1 2 3 7 1 2. Sorry, I'm not sure my mouse is showing. So, but 1 2 3 is this. 1 2 3 is this, and 1 2 3 is this. 1 2 3 is this. 1 2 3. Sorry, something is wrong. So 1 2 3 is this, and 1 2 3 is this. 1 2 3 is this, and 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 1 0, and it remains 1 digit to complete this value. But somehow our compiler sorts it out for us, or binary format. So this is what it's going to do. It's going to add 0. So that's what we call padding. That is how the word padding comes to existence. That wherever we have our value left empty, and it added 0 for us automatically for us, and help us have an added 0. And when it adds 0, so in the memory, so when we have 0 0, sorry, we have this. So when we have 0 0 1, so 0 0 1 is what we call 1. So it gives us the value of 1. So I hope this is getting cool. So that's it for the octal system. And okay, I have explained padding, and okay, good. So let's try and go to the last one here. So I hope you get what we have taught in today's lecture. We talked about it talks about, sorry guys. So in today's lecture we talk about number systems. We take binary, we understand binary format, and we understand octal, decimals, and hexadecimal. So these are the devices, and we actually go through the review of this. We have, so by now we should have understand what all this means and what all this does to your system. But today's lecture we are supposed to take variables and data type, just because we have to understand how our value is being stored in the memories of our data type here, or how our value is being stored. Like when we have 40 and when we have 20, so how are they being stored? Like that's why we do the introduction, or that's why we bring the introduction of number systems. So through the introduction of number systems, we know or have ideas. So this is just the data type we have, and this is just the data type we have. So but this is not all the data type we have. We're going to be explaining that more about that in the next lecture. So in this one here we have the binary format, which actually holds 8 bits, which actually holds 8 bits in memory, which is 1 byte. So 8 bit, which is 1 byte, and 8 bit again, this is 1 byte. So this is 3 bytes. So 1 2 3 4 5 6 7 8. So this is another 8 bits here, so which is 1 byte. So this is 1 2 3 4. This is 4 bytes of memory. So this is going to be 4 bytes of memory. And now we have this one shows here, we have this explaining us our normal way or normal value we have in our real world, and we have what we trying to understand that this value in our programs, or we use in our programs, are being converted to binary system. All these things we have, they are seated in our memories like this. All these things we have, like the value we have here, which is David, they are seated in our memory just like this, not in this David format, or not in this 123 format, or not in this 12.11 format. They are stored like this in the memory, and more like that. So they are stored like that in the memory. And when we have the next one here, when we have the next one here, we talks about number systems. We talk about binary, we talk about octals, and we talk about hexadecimal. So then we talk about decimal though. So this one we actually use the real world format, or the real world forms of base 10 number, and we sort it out just to show how we can actually convert our binary to decimal number. So we make up this particular computation to sort our binary we have here, and we get 42. I guess we have 42 there. Am I sure? 42, is it 42? Let's try and get it again. 42, is it 42 we have the other time? So we have 1 0 1 1 0 1. No, it's not correct. So 1 0 1 1 0 1. Yeah, 45. I'm wrong. So but I guess I know it's 40 something, but I don't know, I forgot. So it's 45. So this is 45 in your memory, or sorry, in your data. This, if you use value of, like now example, like now if we use the value of 20, if you use the value of 20, let's try the value of 20. Let's see how our binary is. So now we're going to go to decimal, and let's just use 20. So 20. So let's go to our binary. So this is the code that in our binary system. So it's going to be 10100. So this is the way it's being stored in your memory. When you store something like this, when you give the value of A, or when you give the value of 20 to this particular lines of code here. So this is the way your computer treats your code. This is the way it treats, or this is the way it sees your programs. It sees it in the way you say 1011 10100. So that's the way it have or treat your binary. This is the way it treats your data. And so such of things we have here, and we do the same thing here to get this particular, or to get the decimal numbers of this particular binary we have here using base 2. And same thing we have here. So we have base 3. So we do the computation of base 3. It stores from 1 to 7. So base 3 is stored for 1 to 7, and we have we start from decimal of 1 to 7, and when we have 3 here, see we have it in memory in this format, and when we check it together we're going to get exactly what we have. So 110, so this is 110, so it's 6. So in memory this is 6, in memory this is 6. So everything, this is how your value is being stored or seated in our memories, or in our binary systems. So this memory is being seated in our binary systems, and that is all. I hope you get that. So I don't really want to waste time. I know this stuff is going to take whiles and stuff like that, so I don't really want to jump, and I hope you understand what this is. I hope you understand this. I explained this. So this is 4 digits, and when you have it here, we have 4 binary 0, which is 1, which is equals to 1. When we get to the real binary system, when we have 40 here, 40 is going to be 1. Okay, this is 1 here. Okay, sorry, this is 3 digits. Okay, this is 40. So 40 is going to be 1. So that is the way your value is being treated. Whenever you use normal value like this, they are seated in the memories of your computer like this. So make sure you have that in mind. When you have your value like this, they are seated like in the memory just like this, not in this format you see it here. And same thing as happens to the 4 digits we have here, and it happens to the 5 digits. Same thing we have there happens to the 5 digits, and we generalize everything here. So try and come to you this knowledge that generalization of the 4 digit of 1 digit to as much as we want here. This is the formula we can use to get that there. You can actually use to get that. So using 2 raised to power n minus 1. So this is just the formula you can use to get it, everything there. So this is the bits, this is the digits of your binary systems, and your in bits memory it stores like this, and this is the data range. So this digit is actually a bit. So 8 bits it stores as 1 byte, and 1 byte stores actually from 0 to 225 in your as your data range. So data range can only be 225. Anything more than 225 in 8 bytes or in memory, it's error. It cannot work. It doesn't work. So it doesn't go more than this, and it goes less, or so it doesn't go more than this. So when we have 16 bits, which is the digit, so we can actually have 2 bytes and store from this 65,535. So that's how our data are being stored or are being read by memories. So you can actually take this in practice and do it as much as you can. So now we have hexadecimal systems, and we have how our value is being stored in hexadecimal systems here, and we have it also here. So we check and get the calculation just the way we did in our binary, in our decimal. So we did the same thing here, getting the values of it. So just try and notice that your hexadecimal value start from 0 and stop at 9, and start from A and stop at E. So this is all the value of your hexadecimal, but we cannot really figure out any the cannot really show also everything here, but I guess when we get to print something, we're gonna understand what that means, and you can use a calculator to get most of your things. Your calculator will help you out to solve most of your things, and it's gonna be okay for you, fine. So now we get into our code, and let's do something. Oh god, we're tired. Okay, fine. So let's try and do something. So in this lecture we're gonna be like, okay, number systems. So it's gonna be 6, and this copy. So I'm gonna write command prompts in runs developers mode. If you have PowerShell, you can actually use PowerShell. So PowerShell will also work. It's just the same way. The PowerShell can also work. So you can also use PowerShell for this particular one here, or you use any PowerShell. You are PowerShell for Visual Studio 2022 can also work. If you don't, if your command prompt is not actually showing up, you can actually use your PowerShell systems actually to sort that out. So let's try and wait for this to get solved and let's walk it through. So now I'm gonna paste my path and I'm gonna write code and point and that. I'm gonna close this. Okay, all right, good. So in our programs there, we're gonna be writing or let's just try and use our code here, and you can create yours. This is mine, and you can just do yours. This is mine. So and so we can have our value like this. So now this is, I just want to make this thing very fast. I don't want to waste, it really exhausts the time and it's really much. So now I'm just want to explain, I always want to show little explanation about this. So I declared my variable and my integer is here, and I stored 15 in the memory. So all this data you see here, we have 0, 7, which is octal. This is the octal value. This is the octal value, and this is the hexadecimal value. So I told you that hexadecimal value usually starts with 0 and x. So every hexadecimal value should always start with 0 and x. Then you give it the value of your hexadecimal. Then this octal start from 0. So 0, 17 is actually 15 in decimal. So all these things gonna give us the same thing in binary format here. Sorry, there's error here. So in binary, binary actually have stuff like this, which actually have O, B, and 0, 0, 1, 1, 1, 1. So it's stored as 15 in the decimal number. So all these things we're gonna see here, we're gonna print the same thing from our memory. So let's run to our code and let's see how it works. I don't like the way this stuff is so big. I will just use I'll just use it like this, and this is then too big. Oh my god, my code is full of junks and errors. Oh, actually there was errors in my codes actually. So these ones I have here is there's errors. So that's one of the disadvantages of using copying and pasting code. I use the curly braces. I use the also I said curly braces. The quotation I used here was different. See, it was of the same time and doesn't come up like this. It's always like this. It's always like this, and that was one of the error that happens here. So you see it here. Very pointing out the error for me is like I have my errors being bunch of errors. So I'm gonna fix my errors. I'm so sorry that I didn't follow the law. I didn't follow the law. I'm actually using my own method. Okay, what's going on? So let me just use. Okay, fine. So I'm gonna delete this particular one here. Same thing happens to this also. So why is this having error? Why is binary having error? Okay. Oh, this is the way binary is being stored. Anyway, I don't think it has error. So now let's try and solve. Or let's even clear all this code, eh? Should we even clear everything like this? Oh god, just giving us. Oh, there's no more error. Or if there's error, we're gonna clear everything off. Okay, I use, oh, instead of supposed to be, I use this particular one. It's supposed to be 0, so it's going to be 0. That's one of the reasons why it's bringing error. So that's one of the reasons why it's bringing error. So I'm just trying to see that there wasn't not supposed to be any error. So C++ 20. So this is the 26. This is the binary forms for it, and we have Hexadecimal say out, and I don't think this is necessary. Say hello world, not necessary. So I'm just trying to say hello world. This is my number systems. So now I'm gonna have every number printed in the same way. So from number 1 to number 4, which has different value here, are going to be printing the same value, because we are penetrating into their decimal format here using this. We are actually declaring hexadecimals value and storing the value of, or having the value of decimal. So we're going to be printing everything out one by one for us. So number 1, so we're going to be having, so to make this thing easier or faster, so we're going to mix and light everything and do what we call copy and paste. So as a junior programmer or a beginner, I won't advise you to copy paste. Copy paste is not a good way of practicing how to code. You have to write your full code so you can know how to adjust error. So you can know how to work with error. Sometimes typographical error can occur when you get to use with coding and you know more about that. But when you get to type, you're going to be having less of typographical error. So now let's try and run this code again, and it's going to work for us. I should be sure about that. So now we have build with GCC. So that's one of the disadvantages of doing copying and pasting. So I would prefer you just start the code norms just the way I used this earlier. So just where I will not have errors being occurring. So I hope you going with me. So it has generated my binary format, so meaning that I have a very successful code being complied, or my code has been complied successfully. And let's try and view what is inside of this. So come on. So now let's view our programs, everything. What is wrong with you? Or am I too fast than you? Oh, okay, now fine, I'm not fast. So you see, they are all 15 in memories, 15 in memories, 15 in memories, 15 in memories. So you see, they are all stores having the same value. So you can actually use binary. You can feel like using hexadecimal if you feel like I want to prove like, oh, I'm in need of hexadecimal, you can just use your 15 and declare your 15 like this. And in binary, you can, if you want to use the binary form mode, or you want to use the octal system, so they are all actually having the same value, and I don't think there's more in back end parts that is so obvious, except you can just try and show up in front end and just, I mean, I don't mean the front ends in a way that it has to be in a graphical way. I just mean in your code. So you can actually have your code in octal, hexadecimal, or binary, but we are good using decimal. So this is just your code printing or giving us the same value in the memory, like we have explained from the beginnings of our lecture, or we can even show it up. We can even show it from our lectures here. So let's just show how, or let's just see from the calculators. Calculator will be that. So let's try and do decimal. So let's give it 15 and let's cancel this is 15 because it's going to give us the same thing we have here. So in hexadecimal, so we have f. Like I said, f. Where's our so like I said, f is the value of our hexadecimal. X is the value of the decimal, but we have to show up, or we have to indicate that we are using hexadecimal by using 0 and x. So using 0 and x, make sure that, or give us the ability to notify, or to give the compiler awareness that this is hexadecimal value. This is hexadecimal value. And also we have octa. We also have octa. Octa is 17. So you see it here, octa is 17, but we actually have 0 in front of every octal value, or every octal value usually have or every octal data usually have 0 in the front before the actual value is being used. So 0, and we have 15, which is actually here, and in the binary we usually have 111. So this 0 does not actually have common value, it doesn't have value, but using one, you can actually use 111, or you can actually use 0 0 0 0 1 1 1. And I said OB has to be indicated. This particular code has to be indicated in the front, showing or indicating that this is binary number. So your compiler is going to see that this is a binary number and going to push it or take us through the binary system and convert this binary to decimal for us. So we are all printing everything we have here in decimal. So we are printing them in decimal over here. So I hope you understand everything. Thank you very much. See you in the next lecture, which is variable and data types. So I'm going to be explaining variable and data types in our next lecture. So thank you everyone. Take care of yourself. And if you don't understand more, you can just comment. I'm going to explain more. I love teaching, even if I'm not good enough. So thank you very much. I'm good. I'm not good enough. I'm good. Okay, bye everyone. No, not you.